Hello, this is Dr. Butler, and this is AP Physics, and we are going to discuss Unit 4, Momentum, the topics of momentum. These are the three main topics. You have center of mass, impulse and momentum, and the conservation of momentum and collision. So first of all, the center of mass. So you should be able to calculate center of mass using point masses and calculate the center of mass using calculus. And then describe this and doing that. These are going to be using the formulas for center of mass. So for the point masses, your center of mass is going to be the sum of all of the point masses the sum of all of the mass times the position of every little particle. So on the mass of one particle times its position plus the mass of the other particle times its position, all over the total mass of the system. So you need to know that, but also using calculus, we would have to do it using the integral function. So it's 1 over the total mass times the integral of your x dm. Now the problem with this is that you would have to convert your dm into a some sort of dx using density, and so you would have to know how to do these things. This is a little bit more complicated process, and the sum of the masses of point masses is a little bit easier to do that. So for example, if you had a meter stick like this, and you needed to find the center of mass of this, and you had particles, you had something right at 10 centimeters, you had something at 50 centimeters, and you had something at 100 centimeters. You would do the position times the mass of the first one, plus the position times the mass of the second one, plus the position times the mass of the third one, divided by the total mass of the system to get the center of mass. The second part here is describe the motion of the center of mass of a system for different situations. And the center of mass for a system, if you, for example, if you had one object of, let's say, mass m, and it's moving this direction, and then you have another object of 2m, and it is moving in this direction, then you would have the center of mass is someplace in here. What's going to happen to that? Describe what's going to happen to the center of mass of that system as these objects are moving. Maybe they're going to move together. Maybe they're going to move separate from each other. But the center of mass of that system is going to be moving. If there's no external forces, that center of mass is going to move at the same speed. And it's not and direction. If there are external forces, then that center of mass would accelerate, and so it all depends upon those things. And then finally, we have distinguish between center of mass and center of gravity. Well, the center of mass is always in the place where there is a center of mass. And gravity varies a little bit. For example, if you had the Earth and the Moon, the center of mass of the Earth-Moon system is right in, or of the Moon is right in the center of the Moon, but the center of gravity is actually closer to the Earth because the near side of the Moon gets more gravity force than the far side of the Moon. So there is some changes between the center of mass and center of gravity, but you have to have really large things that are being affected by gravity to have that. The next topic is impulse and momentum. So being able to calculate total momentum in a system. To calculate total momentum, you are using momentum, which is a vector quantity, equals mass times velocity. So be able to use those formulas to calculate it. So the relationships between mass and velocity and momentum are in this formula. So if you have a moving object and you needed to find one of the other things there, you could do that. Calculate the rate of change in momentum is determined by an external force. So in this, if you have a change in momentum, which in calculus is dp dt, that is going to be determined by the force. So dp dt equals our force. So there is a relationship between momentum and force that you could see with this. And that is looking at that. Fourth thing is use impulse to determine quantities such as force, mass, change in velocity and collisions. So I'm going to look down here. We're going to be thinking about impulse a lot. We're using J for impulse. J is equal to your change in momentum. And that is going to, and this is if you're going to consider average forces. And that is going to be equal to your force, your average force, times your time. So, and being able to use this function right here, times time, times whatever change in time it is. So you can calculate things like force. You can calculate mass, because momentum is mass times velocity. You can calculate a change in velocity, because mass times a change in velocity equals momentum. So using impulse to do that. So can calculate impulse using average force, and then that's this one. And then you also calculate it using calculate impulse using a changing force. If it's a changing force, your impulse is also going to equal the integral of our force as a function of our force as a function of time times dt. And so you have these formulas for impulse that are very useful to determining things. So and this is going to equal our impulse, which is always the change in momentum. So how the momentum changes is reflected in that. So then the next point here is describe relationships between the momentum of individual objects and the momentum of the center of mass of an object. This is if we have an object, let's say I have A is sitting right here and B is coming in at it. So there's going to be a change in momentum of B when it hits A. There's going to be a change of A when B hits it, but the overall center of mass momentum should not change as long as there's no external force acting on it. Okay. Calculate the momentum using graphs. So if you have a force times time graph, then a force versus times graph, if you know what the force is over time, then you can calculate the momentum by finding the area under this curve. And then calculate the force, the change in momentum using calculus, which is already been done right here. And as you should know, graphing and calculus go hand in hand with those. So impulse and momentum, very powerful concept when you're talking about systems of particles and particles moving under a force. And finally, conservation of momentum. So in conservation of momentum, you need to be able to, so we have explosions or we have collisions. These are going to be the most common ways that you are going to be looking at how does momentum of a system change. Well, the conservation of momentum says that the momentum of a system stays the same before and after, as long as there's no external force acting on it. If there is an external force, then you have to broaden what you're calling your system in order to make momentum conserved. So in collisions, when you have explosions, when you have two objects hitting each other, an explosion is where parts of an object spread apart, and collisions are where two things come together. You need to be able to calculate the velocity of one part after it. So again, if we have A coming in at some speed v, and then it hits B, and if B is not moving, that's great. But then what happens if A and B afterwards are moving together? If they move together, what is going to be the speed of the combined afterwards? Well, you should be able to calculate that. Or if they don't, if they bounce off of each other, what is going to be the speed of one part? In the same way, collisions deal with energy as well. So you should be able to calculate changes in energy when something like this happens. In an explosion or an inelastic collision, the energy is not conserved. And so you can calculate how much energy is lost to heat in those things by using momentum conservation to get to energy changes. Because you could calculate your energy by using 1/2 mv squared to see what those things are. If it's an elastic collision, then the energy should be conserved as well. Calculate changes of momentum or energy as a result of collisions. So you have the whole momentum before and the whole momentum afterwards. The whole energy before and the whole energy after, what happens to that? Or you could need to calculate the change in momentum of a part. What happened to A in the collision above? What happened to its momentum? What's its change in momentum? What's its change in energy? So being able to connect those kinds of things together. Distinguish between elastic and inelastic collisions. So elastic collisions are when they bounce, and inelastic collisions are when they stick together. In elastic collisions, both energy and momentum are conserved. In inelastic collision, only momentum is conserved, energy is not conserved. Some energy is going to be lost to heat. Next one is describe what is conserved in a collision. So it's either going to be momentum, or it's going to be energy, or it's either going to be momentum, or it's going to be momentum and energy. And so you have to describe that. Calculate the speed of a center of mass in a collision, kind of a similar thing to what we've talked about. And then 1D versus 2D collision. So in 2Ds, you need to consider the X's and the Y's. In 1D, you're just looking at those different things. In 1D, you can look, between speed, well, I shouldn't say speed, velocity and in momentum are vector quantities. So direction matters if it's going in the positive direction or in the negative direction. Energy and speeds are not, and so those are not going to matter in terms of direction. That goes for two-dimension as well. There is no X kinetic energy and Y kinetic energy. There's only kinetic energy. But there is an X momentum and a Y momentum, or an X velocity and a Y velocity. And so you have to consider those things together. All right, so that's the overview, and hopefully we can chat about that